Welcome back to Rocket's Office Hours. Today we're just cruising through the setup of some examples of finding areas between curves, okay? So this first example, I've got the two curves, y is cosine, y is equal to sine. So I did my best trying to draw these, okay? So y is equal to cosine is this curve here, and then y equals sine is this curve here. And the area I'm looking for is going to be right here, okay? That's the area I'm going to restrict myself to. So the question I want to understand is, am I going to do integral of top minus bottom because I'm looking at y equals some function of x, or am I going to do something like I'm going to do over here where I'm going to do like right minus left because I have x as a function of y, okay? So in this case, since y is defined in terms of x, I'm going to choose to do top minus bottom, okay? So remember, first thing I need to figure out is over what region? So I need to figure out what is this left point because that's where they intersect, and what is this right point because that's where they intersect. So what is that really saying? That's saying when are the two y values the same? Okay, well that's saying when sine and cosine are equal to each other. Well, I go back to my unit circle, okay? So I look at the unit circle and I say, well, when are they equal to each other? They're equal to each other on the line y equals x. So in particular, at this value, this is going to be pi over 4, and the value here to here is going to be 5 pi over 4. Okay, so those are going to be my values here. This will be pi over 4, and this one will be 5 pi over 4 there. Okay? So then my area is very simple. The formula is just going to simply be a is equal to the integral of pi over 4 up to 5 pi over 4 of what? This is the top curve minus the bottom. Okay, that's our setup every time. And it's with respect to x because I'm moving along the x-axis and my bounds are in terms of x. So I need to say, what is the top curve versus the lower curve? Well, over this entire range, the top curve here is given by sine of x. So this will be the integral from pi over 4 up to 5 pi over 4 of the top curve, which is sine. And the lower curve is what? The lower curve is this guy right here, which is cosine. So that'll just be cosine of x dx. Okay? Now, we could work through this, fundamental theorem of calculus, anti-differentiate, evaluate at the endpoints, and subtract, all of that, but ultimately, what we're looking for is how do we set these things up? You can take it the rest of the way. Okay? So now let's look at this one over here. This one's a little bit different because x is given as a function of y and x is given as a function of y. You might look at these curves and be like, wait a second, the vertical line test fails, these aren't functions of x. And it's like, yes, I agree, but if you look at the vertical line test this way, in the sense of like x is a function of y, then obviously this is kind of like, this is a nice parabola, satisfies the vertical line test kind of going this way. This one's a parabola going this way, again, vertical line test that way. All right? So what's the area I'm interested in? I'm interested in this area here, all right? So to find out what that area is, we first need to, again, figure out what is the range over which I'm going to be integrating, and that's when the two are going to be equal to each other. So when the x values are the same, right? These x values are the same. I'm saying, what are the y values? Y goes from where to where? Well, I'm looking at when 3 minus y squared equals y squared, okay? So 3 minus y squared is this one, and x equals y squared is that one. Okay, so what do I get? Let's see, if I add y squared over, I get 2y squared equals 3. Okay, so these aren't going to work out so nicely, but that's okay. That tells me that y squared is equal to 3 over 2, which tells me that y will be plus or minus the square root of 3 over 2. Now, you might get freaked out with the bounds a little bit, and that's fair. Those numbers are not great. However, we're just trying to set these up, so we're not going to actually evaluate this at the end of the day. Okay, so what's my area going to be? So whatever a is going to be the integral from the lower bound, which is minus the square root of 3 over 2, okay, up to the upper bound, which is the square root of 3 over 2, all right? And so this will be minus the square root of 3 halves to the square root of 3 halves, all right? Of what? Well, now because these are functions of y instead of x, what we do is rather than doing top minus bottom, okay, what you do is you do right minus left. Okay, so this is the right curve minus the left curve. Okay, and this is with respect to y because my bounds are with respect to y. Okay, now why is that the case? Just go back to the example of top minus bottom and think of the picture. If you were to kind of like tilt this picture vertically, you'd say the integral from negative root 3 over 2 to root 3 over 2 of the top curve, or the right curve, if you will, which is the 3 minus y squared, would give me all of this area all here. But that's too much. I need to subtract away this area, which is the integral of the left curve. And so if I subtract those two things away, I get the area that I'm interested in, okay? So at the end of the day, what do I get? I get minus the square root of 3/2 to the square root of 3/2. What is the rightmost curve? The rightmost curve is this thing, which is given by that equation, so 3 minus y squared. And I subtract off the leftmost curve, which is this one, which is given by this equation. So that's just subtracting off y squared dy. And that's just a quadratic polynomial. So when we integrate it, that's just the power rule, and then we can fundamental theorem of calculus this to get the actual answer, but you can take it from there. Okay, but that's how you set them up. Here's some examples on how to do it, where y is a function of x and where x is a function of y. All right, like, subscribe, comment down below, ask me questions, send me questions that you want me to answer in other videos, things like that. We'll keep going.